In this video, we're going to take a look at the derivatives of trigonometric functions. Now, some useful trigonometric identities are these two sum identities for sine and cosine. Also, I'm going to show you how to find the derivative of sine x using the definition. So let's recall the definition of the derivative. So that is f prime of x is equal to the limit of f of x plus h minus f of x all divided by h as h approaches 0. So we're going to use the definition of the derivative to find the derivative of sine x. All right, so f prime of x is equal to the limit, and we're going to take the x plus h and we're going to plug it into x where it's sine x. So it's going to be sine bracket x plus h and then minus f of x, in this case it's sine x, all divided by h as h approaches 0. Okay. So we're going to use our sum identity to expand our sine x plus h. So this becomes sine x times cos h plus sine h times cos x and then minus sine x. And then again, all divided by h. All right, so I'm just going to do a little bit of rearrangement here. So let me write the limit again. I'm going to take my sine x and my cos h, and I'm going to move that together with my last term, my minus sine x all over h. And then I'm going to add, as a separate limit, I'm going to split up this part over here. So I'm going to write that as sine h times cos x also divided by h. All right, so now what we have is the limit as h approaches 0. I'm going to factor out a sine x from the first limit, and I have cos h minus 1 all divided by h plus, now if you recall, when I plug in h is 0, I'm going to get 1 for sine h over h, but I'm going to show you how to do this so that it's all separate. So I'm going to times this by the limit as h approaches 0 of cos x. Okay, so now we have to recall a couple of limits that we've done before. So the limit as theta approaches 0 for cos theta minus 1 over theta is 0. So that means that this part here, when I have that separated, that's actually going to just be 0. So this first limit will be 0 plus, and the other limit you need to recall is that the limit of sine theta over theta as theta approaches 0 is equal to 1. So then that means that this whole piece is 1. So plus 1. And then we have 0, and we're going to plug that into here. So that would be, oh, actually, there is no h. So we would say this is cos x. So that means that f prime of x, when we simplify all of this, is cos x. So we can conclude that the derivative of sine x is equal to cos x. Now you can find the other derivatives, cos x, tan x, cosecant, secant, and cotangent, using a similar method. Okay. However, to make it easy, I've listed them here in this box for you, and so you need to memorize them. So the derivative of cos x is negative sine x. The derivative of tan x is secant squared x. So the first three you should definitely memorize for sure. The cosecant x, secant x, and cotangent x, those ones you should be able to recognize. So some couple of pointers that you can notice and some tricks is that you notice that all the ones that begin with c, cosecant x, cos x, and cotangent, notice that all of its derivatives are all negative. And then if it doesn't start with a c, they're not negative. Cosecant x, the derivative is cosecant and cotangent. derivative of secant x is secant x and tan. But notice that secant x and tan, they're usually related. So you can see that they have a combination here. And also the derivative of tan x is also secant squared x. So they're very related. And then lastly, the derivative of cotangent x is negative cosecant squared x. So maybe as a last example here, let's derive the derivative of cosecant. And to do that, we're going to use the fact that cosecant is a reciprocal of sine. So to find the derivative of cosecant x, that is the same as finding the derivative of 1 over sine x. And even better, we can also even think of this as sine x to the power of negative 1. Okay, so now we can just kind of use our derivative rules from before. So this equals, we're going to bring the negative 1 down, and this will be then times sine x to the negative 2, and then we have to use our chain rule, and then we take the derivative of sine x, which we now know already is cos x. So now we have negative cos x over sine squared x. Now, the derivative, if we can see, is actually this over here. So if I rewrite this as 1 over sine x times cos x over sine x. So what I'm doing is I'm separating the sine x into two parts. And when I multiply, I will get back this quotient here, the cos x divided by sine squared x. But now I have 1 over sine x, which is cosecant x. And then cos over sine x is cotangent x. And this is negative. And so now you can see that the derivative of cosecant is actually negative cosecant x, cotangent x. And I've also shown you how to find the derivatives using the chain rule. All right, let's actually now take a look at some examples where we need to use the derivatives and also apply our rules of chain rule and also implicit differentiation. So the first one is quite straightforward. We have 3x cubed, so that one doesn't even have a trig. We bring down the 3, so 3 times 3 is 9, and then x squared. Derivative of cos x is negative sine x. So remember, the cos x is always going to be the opposite sign. And then that's it. On the next one here, we have 4 times cos x cubed. Now the 4 by itself is a coefficient in the front, so we're going to leave it as just 4. You can ignore that. You can do a product rule, but you don't need to. So we're going to have the 4, and now we're going to derive cos, which you know is negative sine. So it's going to be negative sine, but we don't change the inside. So we have to apply the chain rule. So when we take the derivative of cos, the derivative of cos is negative sine, but we're going to leave the x cubed inside. And then as a separate step, we're now going to take the derivative of just the x cubed part, which would then be 3x squared. So now we have negative 4 times 3, which is negative 12, x squared, and then times sine x cubed. And then that's how we leave this. All right, now the next one here, y is equal to sine, and then the square root of 1 plus cos x. So we have y prime. So we take the derivative of the outside, which is sine, and that's going to be cos. We're going to leave the inside. So that would be 1 plus cos x. And then the next outer or the inner shell would be the root 1 plus cos x. So to find the derivative of that, we can think of that as a half, or exponent as a half. So we're going to multiply this by 1 over 2. And then we'll have negative a half as our exponent. So I'm going to move this to the denominator. And the 1 plus cos x still stays as 1 plus cos x. So we don't change that part. And then finally, now I'm going to multiply the inside, which is the 1 plus cos x. And the derivative of 1 plus cos x is 0, and then minus sine x. So that's going to be negative sine x multiplied by at the end. So combining this all together, my numerator is composed of the negative sine x times the cos of 1 plus cos x, all divided by 2 root 1 plus cos x. All right, let's do one where we require implicit differentiation. So for h here, we can see that we have an x and a y, and they're on both sides of the equation, which means that we need to then do implicit differentiation. So we first take the derivative of x, which is 1, and then we have times sine y plus x. Now we take the derivative of sine y, which is cos y, and then we write dy dx equal to, on the right side now, we take the derivative of cos, which is negative sine. But remember, we leave the inside, so it's going to be x plus y. And now we're going to take the derivative of the inside, which is this part over here. And so that's going to be 1 plus also 1. But because we're taking the derivative of y, we also times this by dy dx. All right, so to do some simplification, I'm going to take the x cos y, dy dx, and that's going to equal negative sine y from over here. We're going to move it to the other side, minus sine x plus y. However, it's kind of hard to see, but this whole expression here is being multiplied by this whole expression here. So when we multiply this, we actually need to distribute this to the 1, and also we need to distribute that to the dy dx. So when I do this, I get the negative sine x plus y, and then I have another minus sine x plus y, and then dy dx. So we want to move all the dy dx's to the left side. So I'm going to take this expression here and move it. So I have x cos y dy dx plus sine x plus y dy dx equals to negative sine y minus sine x plus y. Factor out the dy dx on the left. So I have x times cos y plus sine x plus y, and then equals our right side still. And then to finish off, we're going to divide by this expression here. So we have that dy dx is equal to negative sine y minus sine bracket x plus y, all divided by x cos y plus sine x plus y. And then there we go. So I've shown you how to find the derivatives of some expressions.